Dooby 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 doo. Dooby 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 doo. Dooby 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 doo. Hey, the intro music. Hey, it's good, isn't it? I do it myself. Welcome, welcome, welcome. Hello, peeps. Yeah, it's a lazy Sunday, and we're on a Rust project, read and write data files. Lovely, lovely, lovely. Okay, let me settle in here a little bit. Yeah, basic function tests. We've had a session now on read and write data files. And we've got some basic functions, and we're testing what the code can do. And the results are unexpected, as the whole file is being read at once. We have managed to save something out into the correct place. So, some success and something unexpected. Let's take a look at that. Right, here we go. Oh, look, I've got a README file. What was I doing? I was looking at a possible solution, boiling it down to bits and pieces. Did an hour's worth of research on this standard library thing. A bit of Google, as you might say. And I've found out that when you use Google, you also get a bit of something like ChatGPT coming up on the screen and giving me suggestions. God, the rubbish. Never seen anything like it. Oh dear, don't use that stuff to make your programs. Never mind, that's something different. So our problem lies in this low data and what we're doing in this while loop, which you probably can't see because I haven't enlarged it, have I? Plus, I think. 1. Might be a bit big. No, I'll be alright. Okay. Run. Bing. Yes, I know. Right. This data. Yeah, that's never being used. Yeah, never is never. Yeah, that's fine. So, welcome to the data files development. Data written to the file, data config. Load data 0, and it loads all the data from the file. Loaded data 1. Well, this is all printed out afterwards. I was wondering in the back of my mind, why doesn't that cause an error? And it's for a very good reason. And that's how that's because of the way data files and files in general are used by the operating system and by languages like this. What we have here is a slight misconception. We can't, well, automatically what's happening in the background is the program hits the end of file marker. And because it's hit the end of file marker here, at this point, when it comes to look at it again, it says, oh, we're at the end of the file marker, we won't need to do anything. So it doesn't. It just says, oh, there's nothing left to read. Here, have a 0 or something to play with. It's not a failed read. It's still reading the file, but it's just coming across a marker that says, well, this is the end of the file, so we don't have to do anything. So yeah, a little hidden thing. It's like the end of a string marker, which nobody ever thinks about. Well, you have to in certain circumstances. And the same with end of file markers. If you don't know they're there, could cause you problems under certain circumstances. When you are searching through a file for a specific object, maybe, and trying to just find one thing in a file. All interesting stuff. It's all under computer science, and it's whether you want to learn it or not, really. But yeah, if you want to know more about that, Google end of file markers. Yes, computer science. Great thing. I think all computer systems or operating systems use that in some way, shape or form. Makes sense, doesn't it? So yeah, files. This isn't the result we want. We want loaded data 0 test, and then we want loaded data 1 test, loaded data 2 test, 3 test, 4 test. Yeah, about that. So, interestingly enough, that's what I was looking at. We can get rid of some of this now, can't we? So our problems here with this read to string business, it's line 64 that's wrong. Well, not wrong, but giving us the unexpected result. So it's obvious because I put a to-do there on line 62. This is loading the entire file. Yeah. Now, the solution is something called buffered reading, and of course, tokenization and line reading. Those are the subjects which cover how you want to load it. Well, as you're loading a file, what you want to do with the data, how you want to interpret or parse the data, I think they call it. Why do they use such stupid words? I don't know. But that's computer science for you. They like to use these strange words. I don't know whether it's to confuse people or just make it into an arcane art at times, but interpret, I think. I'll use English. So we don't want to read a string or read to string. We want to do something different, and that's what I was looking up here. We want to make a buffer. So we can place the data in the buffer. We can create a sub-buffer, which is a string. I mean, a buffer is just an area of memory where it's going to dump whatever it reads off the disk. That's the easiest way of describing that. It's usually just raw memory. A block of it. In this case, I think it's about 8K. That's what somebody said. I haven't been able to verify that or anything, but it sounds about right. So as long as we're not reading in too much, we should be fine. But look at this. Read line. I think we should look at that. So let's take this first line, and we need that somewhere near our file. Open the file, and we're going to buffer it. So let's pop that in there. So we've now got a reader variable, which is mutatable, of course, because it's going to be changing the data within the memory area or the memory block. Let's have a look. Let mute number of items equals 0. Yeah, that's fine. Current string. Do we want it here? Probably, because we're going through a while loop. So this... oh dear. It's going to go here. Yeah, that's okay. That is going to go there. I/O. Bet we haven't got I/O going, have we? We haven't. So I'm just going to pop in self, comma. Alright, that should get rid of some of the errors with a bit of luck. There we go. Yeah, we're not using it yet. Value moved here. Oh. Well, that's interesting. Because if it moves, we'll lose it. Can we not just reference the file? We can. Okay. So that's just sending a pointer now. I don't know if that's going to work. Let's have a look. Interestingly, they're not sending in a pointer. Okay, fine. So how do we use this reader? We get a string. Yeah, we're already doing that. We've got this reader.readLine and mute line, expect an error. Okay. It's looking interesting. So we're not using this current file. I think we're just going to replace this. So we're now reader, read line. Okay, what does reader give back? Reader.readLine. In the current scope, quick fix, import, standard I/O. Alright. So, and mute line is a buffer, which will be data current. you in there. Error message is unable. Can't read the line. I'll do. And then we're printing out the data. I don't think that works. Just clean that up. Ba ba boom, ba boom, ba boom, boom. Still not liking something here. Current file. Variable does not need to be mutable. Okay. I'm not sure about this ampersand sign. Alright. I think we're close. Just gonna run it and see what happens. Ooh, look what we got. Look what we got. Everything's in the correct place now. So we are reading a single line. That's important. That's very important, because that means we've now got our code correct. So that's the answer. Interesting. Well, it's reading the standard library. I wouldn't have come to that conclusion. You see, the notes and everything in the standard library for this buffer stuff seems to lean towards like communications across networks, TCP communications and stuff like that, which you do need it for. I wouldn't have thought we would have had to have used it here. This is no longer doing that, so that line can go. That's fixed. Lovely. Check this item of data in case we need to serialize. Oh dear, yes. Because we're going to start swapping up our data now. Okay, let's find our coffee. This is interesting, because now we've got to the core of the problem. Well, problems and solutions, or got to the core of the solution. We've got the basic code now to be able to read and write to a file. But we know we are restricted in this buffer reading thingy. That worked. Wow. Well done, me. Don't need you anymore. Ba ba bum ba bum. That was just like 20 minutes researching around and half an hour then spent thinking about it and then deciding on what I wanted to do. And this is what I wanted to do. Yeah, check. So if it isn't a string, we have to convert it. From a string to its data type. So we need storage. Data loaded from file data config. Yeah, it does get to that line. That's good. So we need to store this data. And then we need to pass the data back to the user. Right, okay. So we have these gaps. And we can't fill them in. Oh, I know what I didn't do. So let's go back to main and have a look what we've got here. You see, here's the problem. What we're going to put in here. I'm going to put an I30. No, I'm going to cheat. I'm going to put a U32 in. Okay. So for the F32, let's put a good number in. For item 3, we should stop doing this. It does annoy me. Can you get it off screen, please? Thank you. It's because of where I keep leaving my mouse. Item 3. Can you see the problem with what I'm doing? We'll shorten that down. Just to test a string. We don't need that much information mulling around. So we've got some gathered data, and we're popped into a variable called test data. So far, we haven't included it in our load, but let's have a look at our save. So if we look at our save file, it's just full of test data, which is fine. I think I know how we do this. My problem is, how do we keep this generic? How do we keep this as a use case that anything can use? I want to be able to drop this file into any application and for this to work automatically. I don't want to have to keep writing this. That's why I do these things. This is what a development environment's all about. So I've got our gathered data. How can we access it? How can we access gathered data? Well, let's play around with it. There's 3 items of data. Okay, so we can save that out. I've got a while loop. That's given us 5 items. So let's pop that down to 3. That might be a good idea because we don't have that much. Let current data equal test. Ooh, we don't want that. Check this item of data in case we need to serialize. Well, we don't. So this is pointless. This is not generic, this is just testing. Do we need an iterator for gathered data? I'm just wondering actually if I do that. Zero, 1 and 2. Yeah, that's right. Yeah, it does go down to 3. Good. Good, that works. So that test is complete. I'm not sure how this language deals with this. What I'm thinking about is how do we do that for items in what, gathered data? No, tester data. That's gonna really gathered data as into iterator item in test data. It did it. Really? Just playing. There. No, don't do that. What does that do? It's doing things into iterator. By implementing into iterator for a type, you define how it will be converted to an iterator. This is common for types which describe a collection of some kind. It will work with Rust's loop syntax, which is what we're using. Sum. Ah. So it gives us a sum value, which means it could be of any type. Right, okay. I understand what sum means now. Oh, it's got it here. Implement my collection, yeah. Okay. Okay. Always wise to look through the manual. This is actually just linking through to what's on the left hand side. There is the manual stuff. I don't like types. I don't like using that kind of thing. I find this when I come across this in anybody's code, I stop and think, why? Why? It's because they don't know what type it is. Isn't that dangerous? I mean, if you don't know what type it is, the computer doesn't know what type it is, who knows what the bloody hell it's doing? Alright. It's saying that this isn't a problem. Why don't I believe it? Okay. Gathered data is not an iterator. Ah, it's trying to make you into an iterator. I get you. Alright. So we are getting an error now. The trait iterator is not implemented for gathered data. Huh. It's a trait? I like this. We want a trait? Huh. How do we do that? Is it a hash? Iterator. Hash derive. It's one of those, isn't it? Iterator. Oh, it's got yeah. Iter. This doesn't seem to be coming up. Deny? No. Cannot find derive macro iterator in this scope. Iterator is in scope, but it is only a trait without a derive macro. Okay. Let's get rid of a macro. Okay. Implement iterator. Right, public trait iterator. It's saying we've got a syntax error. That's okay. $247 implementations, for God's sake. I'm not reading all that. Macros, modules, keywords, primitive types. Does it come to macros? Keywords. Okay. Alright, that's coming up with something. That's why I have this open. Standard iterator. A trait for dealing with iterators. Hash pling. Feature. Lots and lots of descriptive stuff. Nothing to do with structures here. Ba 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 ba. Zipping things, wow. These are all interesting. It is derived that I want though. Huh. I don't think what I'm doing is correct. So let's not do it. I think I might have the wrong end of any kind of stick that I might be holding. So let's rethink that. So this isn't really... working. We've got 3 items. Is there a length? There might be a length. No. Size? Sum. Okay. Just out of interest, I'm allowed to do that, but then would need item 0? Is that how this thing works? No. No, it isn't. Oh, got you. So let's test data, isn't it? Test data dot item. No, we can't do it that way. Item. Might be able to do it that way. Cannot index into a value of type. That's what I wanted to hear. That's the error I was looking for. Good. So we can't index into it like an array. Which is what I was expecting. So how can we access it? We do need some kind of iterator, don't we, for test data? So what we need to know is, how do we iterate or index an individual part of a structure? We're going to have to pull data out of structures. How to... Well, we think it's iterate. Iterate a structure. Let's ask the question. And there we go. Look, it's doing it. It's doing this got it one moment thing. So I've obviously asked the right question now. Now I know what question to ask. Oh my god, what's it doing? Dude. It's giving us more rubbish code. Lovely. I love it when it gives a load of rubbish code. My collection holds a vector of integers. Okay. Alright. You need to implement the iterator trait. Iterator for Michael. Oh god. You have to do it that way, do you? Alright. I see. Why would I need to do that? Why doesn't the language do that? There's a few things about languages in modern day that they fail to do things, like open Windows, for instance. You're on Windows. Why don't we have, in the language, create window? I don't know if we do or not in this language. I haven't looked. Maybe we should. Alright, iterator for my collection. Okay, this is starting to look a bit dodgy. While, you're using a while loop. Into iterator. Alternatively, so we're still implementing an iterator for item in collection, which is what I'm trying to do, and then print the item. Yeah, this is the solution that I'm after. Summary, thank you. But we have to do this implementation. What's that implementation doing? And why do we have to do it when it's obvious that this is the kind of thing that people need to do? That's a bit strange. Item into iterator. Yeah, I understand that. Self items into iterator. Alright. Let's have a closer look at this, shall we? So what it's saying is that did he do it wrong? No field. Yeah, I know there isn't. There's an index in there. Why have you put an index in there? Oh, right, yeah, because that's, yeah. Silly me. Well, item isn't an I32. I see. Can you see the problems we're causing ourselves? And it's all because the different types. And I knew this was going to happen, don't worry. I'm interested though. There we go, item 1, 2 and 3. This is wrong then. This is where those T's come in, isn't it? I'm not doing that. I refuse to. I'm not doing a type T. I had enough of that in C++. It just causes a confusing mess. We've got a type ID as well. Jesus, we can actually get types out of these. Yee. Cloned, copied, wow, filtered. Look at what it can do. This is amazing. Oh, yeah, we do have a size. Scan. More stuff? No. It's just the same stuff as that. Okay. So what they've done is they've this AI has crafted a situation which will work for it. So this can't be done. Not in the way that we're looking at it, which means we've got something wrong in our programming approach. It doesn't mean that this is impossible to do. It's telling me that this isn't right. So that's not right. No field self on type gathered data. Available fields are item 1, item 2 and item 3. Do we have to do each one individually? Okay. I'll go into that. But it's a string. What is this for? The type of the elements being iterated over. Oh, God. That proves what I was saying, though. Our data's wrong. This is not how we should be representing data in a program. And this is a conclusion that I'm trying to come to without actually saying it. So really, I think I've got it. Our gathered data should already be serialized. This shouldn't look like this. This should just be data. The correct answer is how have we structured our data? And it's not serialized. You see that we were talking about that last time, that we need to serialize our data? And it's not a string, it's a vector. So that's a vec. That's the correct way of doing it. That becomes a string. Yeah. Into iterator, standard vector, into iterator I32. No, it's a string. This now becomes data. Can I not have a vector of strings? Found macro, vec. You want a capital V. Alright, you can have a capital V. Is that any better? Thank you. Gathered data. Cannot find type gathered data. Of course you can't. Because we changed its name. Okay, self. No field self on type serialized gathered available field is data. Ah, that's because I got a dot self above it. No. Yeah, possibly. Yeah, there we go. Right. And that's the correct. What I'm going to do then is I am going to do a hash derive. And we are going to put in default. There's a reason for that. Alright, we're allowed to do that. So when we come here, we don't really want to be doing this. What we want to be doing is that. No, it's not that anymore, is it? And that's going to be default. Okay, that allows us to do that, which is correct. So now we've got our serialized gathered data, we can add our data to it, I guess. So test data dot data dot push and a value. We know it's strings, so let's put in our first value, test, string, doesn't really like that, does it? We found that. We would, wouldn't we? There's a sizing problem. Do I want strings or do I want STRs? I want strings. There's a big reason for that, and it's stack and heap, where the data is stored. I don't want this on the stack. I want it on the heap. As toString. We can do as. Okay. The reason I don't want it on the stack is that the stack is limited, and if you've got large amounts of data in a program, you don't want to be holding it in a limited memory area. You want to be holding it in general memory, which is called the heap. Another bit of computer science for you. So yeah, that works. Okay. We can repeat that as much as we want now. We're going for 3, aren't we? Test data. This would be somewhere else. This is just for testing. So we had, what was it? 69.9. Does that work as toString? Does that actually work? No, 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 that does not work. Okay, so we have to use the dot. Yeah, okay. We wanted a uint, didn't we? What does push do? It just puts it into a vector. Push back in other languages sticks it into a vector. 42. Okay. So we've got this rubbish. We've got this rubbish. We should now be able to do items in DoFree. And that would now be an item. Okay. Found struct layer. You might want to surround a struct literal with parentheses. Okay. It's given us a different complaint this time. Do I have to dot that? In parentheses. No. Ah, hold on a minute, it's done something. It's starting to come up with a type. Serialize, got you, to item, got you. As into iterator, yeah, got you. What is it looking for here? Oh. Is that what it's looking for? I'm just following the example that they're giving, and I'm not certain why this is the problem with these kind of things. Data is unknown. If we're implementing an iterator, okay, we've got a vector. Okay. We want to get inside that vector. And it's not doing what I'm expecting it to. Iterate over an exclusive range up to, yeah, okay. So is this wrong? Or is this wrong? Well, this is wrong, obviously. 2 implementations. Yeah. I'm going back to item. Do I need a colon here? Data? No. Dot data? No. I don't like this. It's not responding in an easy to work out fashion. Huh. Okay. I think I'm getting somewhere with it. Cannot find value data in this scope. Not found in this scope. Okay. Missing field data in initializer. Ah, it's initializing. Ugh. I don't want it to initialize. Huh. Iterating over arrays, yeah. Describe. The goal is to create a macro which automatically derives the describe trait for any struct like this. Why? We can see that this is very problematic. How do we handle our data? Reverse engineer, okay. Sin. Oh, God. Yeah, you're going off into a rabbit hole here, mate. You're using a crate. Sorry. We're not interested in crates for this. Oh. Pop it into an array. That's an interesting solution. It's not possible to iterate over the fields of a struct, but you can solve your problem another way. You can convert the vector 3D to an array. That's an interesting idea. So what we could do here is a function using that kind of idea. Let's try that. Let's get rid of this for a second. Let's try something slightly different. So it would be a public function, obviously. As it'll have to be a vector. No, we can have an array. We're allowed an array of strings. We can try that. We know it. No, we don't know its size. Hold on a minute. I've just had multiple ideas just flood in at once, all together, all at the same time. Just trying to sort through them. Do we need to serialize at that point, or can we just serialize as an array? And stay with gathered data. Eek. We could serialize at this point. That's interesting. I'm going to go back to vector. And self. We're going to output something or other. A vec of string like that, and all we're going to do is create a vector. I'm going to just put in this a minute and see what it says. So we don't need the let. We can just use self.data. We don't want that. It's a return value. Now, cannot move out. So we can only have a reference to that. Consider borrowing here. Consider borrowing. Alright. We'll do it. We'll do it. We'll borrow the data. So what we're doing is we're borrowing the data out of that. So we're not doing this anymore. Oops. Let data equal serialized gathered data asvec and self. Why have you put that in? Not sure. Let's find out. Yeah, it's not going to like that. It takes an argument. Did I not put it inside an implementation? I did. Oh, well, back to this, are we? Why is it... This is unusual. I don't want it to do that. That's not how it's responded in the past. But this is getting the data out of the structure and the vec string. Ah, is it me that's done it the wrong way? No. It is a colon, colon. For God's sake. Why do we need the why do we need asvec? Why can't I just do that? Because it's not constructed. I'm using the wrong bloody thing. Hold on a minute. Hold on a minute. Hold the phone. I think I found out what I'm doing wrong here. I think I've worked it out. Oh God. It's doing all this garbage again. Okay, we'll let it do its garbage. I think I've worked it out. Not an easy one to work out because I don't really want all of this code. It's not in that. It's in that. That's what I want. Well, it doesn't work because we can't do that as iterator. Okay. Alright, we'll reset this up. All of this went completely weird now. This could turn out quite interesting, to be honest. Yeah, we do need that to a string. Ba 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 bum ba ba bum. We need that to a string. Self.items is now data. And we should be okay with that. Why are you complaining? Cannot mutate immutable variable test data. Okay, fine. Looking down here, now works. So no, they didn't get it wrong, it was me. As usual. Data files is now up the creek. Because this is all now wrong. This is one of the reasons I don't like messing around too much with this stuff. Because it affects everything else. This is the problem that happens when you start messing around with stuff. Check data directory is fine. You're not fine. Alright, we've got something that's going to run. Yeah, we've got something that's going to run. Thank God I didn't use it all over the place at this stage. Alright. Check our test data. Alright, that's correct. That's just random values. What's this gonna do? This is just a testing thing, so it's just going to print it out at the end, isn't it? Interesting idea. So I've got test string 69.9 and 42, it works. Oh my god. So we have to serialize before we can use our data files. Right. That all makes sense. So we've got a vector of strings. Now, we didn't tell this how many strings we had, but it did print them out properly and iterated properly. So that is a solution. And it does say string. So this is going to go into our save file. Awesome sauce. So when we're saving out, we don't want to loop through our data. We want to iterate through our data. So it's not a while loop anymore. So let's get rid of the while loop. let's get rid of that. So let's iterate through our data. We've got a for loop. So we've got a different type. Check this item. Okay, we don't want the print. I'm not here to print this out. Let current data and str equal test. Ooh. In case we need to sit, we've already serialized, so we don't need that anymore. Okay. Save the current item. We don't need to know how many items there are anymore. This is interesting. Let's pop you, save that lot there. Okay, let's pop you into here. Test data's just gone a bit wonky. Test data in this scope. No, you won't be able to. Because we've got it as a different value. It's all data. So there we go. That's now working. Ish. Yes, it is. For and. We need to dereference it. Yeah, we dereference it. Okay. That gives us a string. I think we can see how this is starting to work. Then we can write a line to our current file using the item, because that's a string. Okay. We can do that. Expect that. Yeah, number. We don't want you anymore. We are going to have problems here because we've got borrowing and stuff going on. That's okay. Cannot move out of star all data. Move. Oh. Which is behind a shared reference. Okay. I get you. And this is referenced for and serialized gathered data. Is implemented for serialized gathered data. Is it now? It is. You're quite right. We'd have to clone the data or move it. I hadn't thought about that. You see how this language explains to you what kind of cock-up you're making? Everything's correct. What we have a problem with here let's get rid of some of these lines, is how to represent our data again. We could clone it, but that's a waste of memory. All data. How do we do it so we just have a pointer? We can return a pointer. I don't know if we're allowed to. Yeah, that's what I was thinking as well. Cannot return reference to a temporary value. We'd have to dereference there. No. Change the self receiver to match the trait self. Method into iterator as incompatible type for trait. Thought so. So we can't do that. The iterator itself is a value. That is not right. Can we deref it? Yeah, you can. Don't know if that kind of thing works. Yeah, that's what I was expecting. Yeah. I agree with that. Can we not just use data? No. Cannot move. Yeah. There's the problem. How do we get past that? If we take off the pointer, well, we've got a pointer to it. A pointer to the data. Oh. No, we can't go that way. That has to be defined by whatever we do on the right hand side. So using structures is very difficult because we can't iterate through them according to Stack Overflow. You can't do that. So there's got to be a simpler solution. And there is, as far as I can tell. So let's step back. We don't want all data. Well, we do want all data, but we don't want this. We want the data. What we really want is a vector of strings. Yeah, we just want a vector of strings. You see, that becomes a string automatically then. So instead of trying to go through the structure, what we should really be doing is looking at the data. Iterating through a structure doesn't seem to be the correct idea. I like the way the language is guiding us. And here, I don't really want all of this rubbish now, do I? I'm going to keep hold of it for a sec. There's the implementation. I find it interesting how this language guides people. Right, we can get rid of that load of rubbish. Save is not that anymore. Save is dot data. What are we passing here? Ooh. We've got this same problem, haven't we? I'm used to vectors being pointers. Are they pointers in this? What is a vec? It's usually a table of pointers. Are we copying the data and it's not telling us? We've got the push. I'm thinking it is a pointer table. The last thing I want to see happen is the data being copied. Let's have a closer look at vec. Does it tell us? It's a macro for initial, yeah. Capacity and reallocation, yes, I know about that. Indexing, we're going to, well, we don't need to do that because we're splitting it. Slicing, yeah. Looking at specific parts of it. Amount of space allocated for any future elements. Blah, 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 blah. Length, yeah. Okay, length of a vector, which specifies the number of actual elements within the vector. Oh, that's nice. We could use that. Okay. Why don't you tell me that it's on the heap? It's like that's on the heap, that's on the stack. I know that. Okay. You're not also telling me whether this is a pointer or not, but I think it is. There it is. Pointer length capacity. And it's on the heap. Fantastic. That's what we really needed to know. So my assumptions that this works in a similar way to other, well, C and C++ is now confirmed. Wonder why it doesn't tell us in here. Huh? Shall we run it? We've got 3 items, haven't we? Yep. So our while loop here isn't going to cock up. Okay. Should that work? We've double checked everything. We've understood everything. We've realised that iterating through a structure is not easy, but can be done, even though Stack Overflow told us it couldn't. Well, sorry, they're wrong. Anything else? Anything I've missed? I understand what's going on. What do we think? There's your answer. It worked. So, what does this mean? And also, data files dev, yeah, I've got a warning. Generated 1 warning, run cargo fix bin, what? Oh, we've still got stupid things going on, have we? We don't need to use that crate anymore. Ha! I don't need to fix that, I can bloody see it, thank you. Right, let's just have a look and see what kind of mess I've made code-wise. Nothing. That tells me my code is correct. We're getting the correct output. We did it. There's still a single problem to overcome with this. We haven't used our serialization yet because, You see, our serialization would take our original idea, because I've now cheated, I've actually serialized it automatically. We don't need that. It was nice to play around with it. We are cheating a little, aren't we? Oh, it puts the comma back in. Classic. But you can see how we would need to structure our data. We'd need to serialize whatever data we had. But would we? Would we do it that way? Well, no, we wouldn't, because this is a useless struct. That is useless. What we're interested in is that. The vector of strings, which we can manipulate. We can do things with a vector of strings. The structure itself is just, well, not useful. So test data itself may as well just be a vector of strings. This is useless. These are the things that become apparent when you do this. So really, I'm going to leave it in because it's telling me what's going on. But it's not needed. So, this structure is not required. We can pass a vec back from serialization. Yeah. Bypassing this structure altogether. So what we would have here is well, it wouldn't be muted anymore, it'd be test data serialized, well, we don't need that anymore, equals a function that serializes our data or gives us the data to be saved. This wouldn't happen here. For testing purposes, it's fine, as it gives us options later on how we want to explore it. And it's the exploration that gives you the knowledge of how these things should be done. Our saved data is suddenly reduced, hasn't it? This isn't passing back anything. And again, this would pass back a vec3. I don't think we deserialize here. I think our strings would be passed into a correct area and deserialized there. And there's big reasons for that, because we can be more efficient about it. I don't think we need deserialization and serialization in the data files area. Right. I don't think we do that operation here. I think we do that in a different place. This is where the architecture comes into play. So we would need a vec3, a vec, a strings. So we would have something like let loaded data equal a vec of strings, please. Like that. Do we do it that way? That's a bool. Okay. Colon, colon. Oh. Vec with capacity. So it's vec. Doesn't give us a type. Vec from. Vec new. Huh. But I want it to be a string. Aha, you see, it's put an unknown thing in there. So that tells me how to do it. That's excellent. Well done, game. And now it comes up with that. It's telling me that that's a bool. It's got brackets. Why? I don't quite know. TA equals, so it's type, comma. A. What's A? Allocator. hate this kind of thing. That was it, that's using macros with capacity. I don't want with capacity. They're using generics. There's supposed to be a comma there. I mean, that's an empty allocator, but it's not right. I'm not sure how to get rid of this unknown. Hold on a minute. Yeah. To specify lifetime, yeah, type. Okay. Why doesn't it tell me that in here? It tells me all of this stuff. These are the examples. Just says vec new. They have to be mutable. Well, that I agree with. That's an interesting idea, because we can insert, push, pop, push to put things in, pop to take things back off the top. I see, you've done it that way round. See, you've put it here. Why don't you put it on the right hand side? That's the first time I've had to do that. There's a bit of inconsistencies going on here. But it'll give us the right idea. We can use the loaded data here now to push back whatever. Value is data current. Moved. Ooh, we do want it to move, don't we? We can no longer do a debug. Okay. That's fine. Number of items plus 1. We don't need that, do we? Yes, we do. We're still doing this 3 thing. Okay, we have to get rid of that. We'll get rid of that in a sec. Serialization. We are still on the fence about that, because this is serialized data. And all we're going to do is pass back our loaded data. Which is going to be a vec of strings. Okay. Okay. And that's going to be our loaded data. There we go, that works out nicely. Everything's okay there. We now can take a vec string back out of here. I'll use the same thing, I don't really care. There we go. For item in loaded data, print line for debugging, just put nothing, we don't really care. Item. We'll just do it that way. Okay. I think we've got the finals nearly. Alright, let's just clean this up. I don't like the loop, we have to get rid of that. So we haven't got the finals. We are very close. All we've got left now is this loop. So we've got a to-do here. Remove loop. Okay. That gets rid of this number of items garbage. Does this work? We're actually doing the whole functionality now, except for the serialization and deserialization. It isn't print line. It's just print. There you go. It works. So our final solution is upon us. How do we get rid of that? We're on our last to-do. Yeah. We've nearly completed what we set out to do. We don't really need you. We've come to that conclusion. So let's get rid of that. Because I now believe it's in the wrong place. So that helps. Weird, isn't it? I need to think where serialization would go. Because we do need to do that. But I also now know that our data's wrong. Our test data is wrong. It's impractical. I don't think I'd set up an application in that fashion. But it's something to bear in mind when you're actually writing your application. You need to know how to set your data up. In fact, that's probably the most important part of programming an application, is how do you handle your data? And that's a big can of worms among just in its own subject. If you handle your data badly, you have all of the kind of problems that we've come across with this file input-output thing. So what we want to do, I mentioned it earlier, end of file. There's an end of file marker. How do we read until end of file? That's the best question I can come up with. I know we know the number of items at the moment, but that isn't really going to be a fixed value, is it? It's just a magical number that we've come up with for testing. We need to loop, so we are going to need a while loop. So we need to know, is there a way of doing that? We've also got a buffer, so this is the buffer flush. But the only thing we want in our buffer is end of file. Huh. how to read a file of unknown length. Yeah, I know about that. Okay. And you're coming up with read file to string. That's not the correct answer. Okay. Until EOF. There. Got that wrong. If it equals 0. That makes sense. So it's until our reader equals 0. And that's not going to happen. Ah, so this gives back something. Something here gives back something. Result, there you go. You see, this is giving a result back of use size. So we do have a let red bytes. Nice. Number of bytes red equals that. How can we use that? We need a use size. We can't use that there because that's what we've got, and that is going to be greater than 0. We could loop and use a break. Don't like. That's the standard way of doing it. This doesn't make sense here. Because what I'm thinking is doing that. that's mutable. Da 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 da. Get out of that. Don't need that. Don't need you anymore. That's a solution. Is that a good solution? No. That's just some kind of fiction. Works. That's a false positive. If we read 0 bytes, then we have reached the, it's usually in capitals, end of file. It's a solution. You see, when I don't like loops. An empty loop which goes on forever. I prefer a while loop to a straightforward loop with a break halfway in it. But if that, there's no extra being, so when that equals 0, this push doesn't do anything, according to this. We should have an extra piece of data at the end. Of nothingness. Because of the way we've done our while loop, that gets executed even when that's 0. Does that make sense? But it's not showing here, so it's correct. But it's not correct, is it? So that's not the correct solution. Even though it's looking correct, it isn't. I hope you understand what I'm trying to say. And I'm hoping that the language would say, hold on a minute. It doesn't. That's annoying. That's a trap. What I'm trying to say is we don't want to push a 0. Yeah, that's right. If number of bytes read is equal to 0, break. That's the other option, the one I don't like. But it never reaches this line. So we've never got this possible overflow going on. You've heard of overflow errors, I hope. Undefined behaviour because of overflow errors. We're now in a loop, so we don't need that. That becomes a let. It no longer needs to be mutable because it's a static variable and it gets killed at that point, and then it gets recreated on the next loop. I don't like that either, that we're creating a variable each time. Okay. Again, does that work? Yes, it does, but this time we're not going through this an extra. We're breaking on this line and coming out of the loop and returning the loaded data. Okay. Right. Loop through each line in the file. It's not our data. Let's correct our notes. That is now in the wrong place. That should be here. Let's correct everything. Okay. That to me is more correct, but it's something I don't like doing. But it's starting to read right now. It's starting to look right. And that's more important. Now I know that I put a lot of lines in because of these notes and everything, but I need me notes because I forget. This looks better than what are you coming up here for? This stuff was coming up with. I think this was coming up with slightly worse ideas. We haven't done the errors, have we? Yeah, well, we're crashing. We're crashing the program on errors, aren't we? Yeah. Okay. So there's error handling to do. We could shorten that. I don't really want to do that. So there is error handling to do. We'll pop you in. I think we're done. We have something that works without serialization or deserialization. It's storing whatever values we put in there, and it's reading whatever values we put in there. And we've worked our way through problematics. We've tried to avoid, by using a loop, an undefined behavior, which isn't picked up by the language, surprisingly. It tells me about unused code, but it doesn't tell me about overused code. I have to do that myself. Okay. So there you go. That is your load data all on one screen. How's about that? Without the error handling. I've cheated. Do apologise for cheating on these error handlings. I just didn't want to go into that whilst I was trying to think my way through a good way of doing this loading of data. It's not simple, is it? Like I said, we have to be careful. Careful we have been. I think that's your final. Do I want to do anything more with these files? At this point, no. As we're in a test area, I would like to go into this serialize and deserialize stuff a bit more. Maybe get rid of this data structure. Okay, so this is a complete thing, isn't it? So I'm going to put it down as the first working solution to file IO. I think that's more precise. That's a helicopter passing by. And there we go. We can play around now and do other things. So we've done it. All complete. What you're working on, done it. Read to string is built-in way of doing what you're doing. No, it isn't. Read to string was the error that we had at the start of the stream. I'd advise you go back and check out the VOD or watch it on YouTube later. We've actually worked our way past that and into buffer reading. Read to string reads a whole file. Doesn't read a single line, which is what we need. Because we haven't decided where we want to deserialize our data. Because our data isn't just strings. So you have to be careful. I needed a more generic, generalized idea so that I can slot in deserialization anywhere I want. I didn't just want to dump the file into memory or into a string and send that out for parsing. So this automatically splits it into lines. We don't need to parse it. We don't need to parse for the end of line character and then split it into lines later so we can deserialize it and assign it to variables within a bigger program. We need to be as generic as possible for this to be useful to any program. So that's the reasoning behind it. Hope that's understandable. You see, this isn't a one-off. This is a development environment. It's a sandbox. Whenever you're using a sandbox, you want to go very generalized. Yeah, okay, that's good. That's good. I wish I could think of a different way of doing this loop. I think we've got a good generalization. Right. Other things I've been working on then, so that's finished. For now. Until I find fault with it. And then it gets worked on again. That's how I do things. I will set up a development environment like this, where I'm looking at something in specifically. And I'll play around with it, and I can play around with it for months and months and months and months, maybe even years, until it can be used by anything. So this we can extend in the future, we can play around with it. It's not set in stone. But it does show that you don't need a crate. I know we haven't done the serialization and all the rest of it, but I think that's a subject that should be looked at separately, and I wish this helicopter would go away. Very distracting. So what else have I been looking at recently? It's not a bad main program. No, I don't want to alter it anymore. But it's just data files, check directory, save your data, load your data, and that just prints it out. So it's 3 lines that you would have to add to any program to get a vector of strings, which you can then deserialize. We'll look at that later. Okay. Done. Oh, something I've been looking at. We have to go to GitHub, don't we? And it's Bevy. I've been looking at Bevy. As you can see. Just ignore that. And we've got this. Now this is a very interesting thing I found with the Bevy. When you do a search on YouTube and you want to do like game development or everything, 90% of the videos are about Bevy. And I thought, well, I'll look at it then. Why not? So I downloaded the whole of Bevy as source code so I could look at it, and made a Bevy game, which is dead interesting. Yeah. It's dead interesting. It's not a game, it's just some buttons. A button, should I say. I was looking at it for the UI and stuff like that. So the example illustrates how to create a button. I got it from the examples file out of here. This is interesting. Because I've got the files from Bevy, we have to run it as Bevy game, don't we? Okay. We'll use that one. So that's the first thing because of the way I've set it up. That's a me problem. So I actually have to tell it to run the games side because there's two things going on. Profiles for the non-root package will be ignored. But look what's happening. It works. Initially, this had me totally befuddled. This is a crate off crate.io, and it's a heavily used crate. And when I run it, I get this. The error is God knows where. Where's the actual error? Listed on internal resource state, blah blah blah, of resource unnamed object. Sub resource 0 is invalid. There it is. That's the error. So, there's an exception happening which is invalid for use as a present source. Now, I obviously looked this error up and found out that this error was reported to the developers of the crate years ago. Why hasn't it been fixed? So I looked into it a bit more. And they said, well, it's a bug with Windows. So I looked into Windows. No, thank you. I didn't really need that extra error. I looked into Windows, and it's not a bug. So why are they blaming Windows DirectX 12 for having a bug when they have an error? It's because DirectX 12 changed in its API slightly. So I looked further into it. And the error is actually there. What is happening? And this is what I do, by the way. I look at things to see whether things are going to be useful in the future or not. What is happening is this line here. Add plugins, default plugins. The default plugins aren't working properly. Which is why I downloaded all of the code so I could have a look at the default plugins. Which is here. Default plugins, I've got the source code for it. I downloaded it all so I could do this. And when you look down here, load this after renderer initialization. Renderer initialization. Ah, Bevy renderer plugin. So that note is in the wrong place because there's your config. That note should be below the config. What it's talking about is a Textura image plugin, that note. Not this line, which it looks like it's talking about. That's beside the point. So winit plugin, Bevy winit, provides utilities to handle window creation and the event loop. That's above the renderer. I wonder if these two are the wrong way around. Oh, it's still going, Jesus. So, yeah, that's all the program does. It works. But, yeah, something's wrong here. We've got assets, we've got the Bevy window, scheduled running, planners, and God knows what else. The panic handler, the log, the task pool, frame counters, time, transforms, which is your 3D transforms for 3D development, but they're using it for 2D development as well, so that doesn't matter to me. They're just ignoring the Z direction for 2D. Diagnostics, input, schedule runner, window plugin. I think your window plugin has to go before your renderer. Yeah, accessibility. What does accessibility do? Non-geo aspects of integrating with that. Something's wrong here. Something's either in the wrong place, or this render plugin isn't doing what it's supposed to do in default mode. And I want to use DirectX 12. Feature Bevy render. No declaration file. Okay. Can't do it that way. So, what really is going on here? Can I go to this one? Okay, plugin state, plugins, yeah, plugins cannot be added yet after app cleanup, yeah, okay, whatever. Plugins add to app self. Yeah. There's the app. We've got your reflects. It's nicely documented, by the way. Yeah, I'm not going to go through that. Bit disturbing, isn't it? So it's not picking up DirectX 12. And when I looked into it a lot, I spent a whole day just rummaging through code. I found out that DirectX 12 isn't actually mentioned in the default implementation as an option. So what they're expecting is that the environment that you're running on holds DirectX 12 or on Windows. And what has happened with Windows is, the change that they made is, the environment doesn't do that anymore. what we can do is ask it to. Yeah. We can manually set the environment for the WGPU backend to be DirectX 12. Like that. Oh. But look at what happened to the app. If I now click on this, clicked. Oh. That took a while. But it's working. Why is it not checked properly? If that's the solution, that you're looking at an environment rather than saying, hey, let's try using it. Then there's something wrong. You can set that to Vulkan if you want, VUL or whatever. Yeah. Bevy, you've had this outstanding for 5 years. Why have you not done it? That to me was a bit awkward. Because when I have a question like that, I'm thinking to myself, why? Because this is the information it should be coming up with here. It should be coming up with a GPU. System info. There's your GPU. And it gets it all from that back end. So this is what it's missing. I'm a bit surprised about a crate that's been around for this long, that they haven't been able to detect my GPU. I think they detect the system info okay, but I'm not sure about, I think it's this GPU thing that they miss. See backend DX12. And that's coming from the Windows rather than them looking for it. I was going to correct the code. I don't know if anybody else has come across this. Well, obviously they have, because it's been brought up as issue after issue after issue on the GitHub repository as far as I can see. And I've read through the issues, and I've read through the solutions, obviously. And there's various solutions to it. And one of the solutions, this is actually interesting. Close folder. One of the solutions, I did a Rust project on it, didn't I? Bevy. I think it's, I was following a tutorial to try and work out what the hell was going on. That's the solution I came up with. What I had to do was actually tell the back end that I wanted DX12. under the WGPU settings. So default plugin, I don't want the default plugin, I wanted it to go to the WGPU settings and actually use the DX12. No declaration found, of course. That says it's in app. Can't get to a definition. Yeah, that's why I downloaded it all, because I couldn't get to anything from here. I'm not happy about that. I'm not going to do any more on it. Christ, I've messed around with this too much. So that's why I haven't been using Bevy. Because the first thing I came across was an error. So that's that. If anybody at Bevy ever gets to see any of this, sort it out, will you? I'm not doing it for you. I'm actually a little annoyed about that one. So it's got me back up a little bit. I've been looking at Windows, the Windows crate, and thought, is it really worth doing? So I've been looking at the Windows 32 API. Yeah, allow Clippy uppercase acronyms. Jesus. That is bad. Got a readme file here. So this is what I've been following from Microsoft, which is create a window. It's a full thing that you get from the Microsoft Learning area on Windows app development, and as you can see, it's all in C++. Well, it's in C, but Microsoft don't understand C. They always call C C++. That's one thing. The other thing is, this is old. I'm going to call it old. This is an API which is pretty old. It's pretty straightforward API. I mean, there's nothing stupendously wonderful there. So our window turns into this complete and utter mess with these things. But we have to deal with all of the Windows API stuff in Rust, so we have to make all the constants, make all the types. These are all in uppercase, which is why I've got that horrible Clippy thing. Then we've got to make our own macro rules. Then we've got to upload the Windows C++ or C. These are C++ header files. So this is all the header files being used. Then we have the kernel as well, header files. Then we have to start looking at procedures, the Windows procedure, and we have to access the C classes from here, like create window exe and the wind class, which it tells you how to fill in and everything here. We've got unsafe implementations because we're accessing the operating system stuff. Great. You can see what a bloody mess it is. Yeah. It works, though. There you go. It's slightly more responsive than Bevy's. Yeah. But the problems that I had with this Windows API was that one word, pol. You see, this blocks. So when you're trying to get to the message system that the Windows API uses, and you want to get your event messages from the operating system, this blocks. So I had to put in a check to return false if there weren't any messages from the operating system. Because if I didn't, this line would run and my program stopped waiting for the operating system to say hello. And it's like, you dozy pillocks. No, it wasn't that. It was, oh, Microsoft. I think in the new modern day English language dictionary, Microsoft does actually come right next to the entry for dozy pillocks. So I think they're interchangeable. But this is what the problem is with old things. So I actually have to peek at the message queue to see if there's any messages. It's crazy. It's crazy what you have to do. I mean, isn't that strange? So we've got our message and a message handling. Then we can look at each message and decide what to do. The painting is awful. Yeah. And returning a 0 at the end, which doesn't look right. But yeah. So a lot of the things in this are a bit weird, but wonderful. It is doable. So if you have a look, there's no dependencies. Is it worth doing? Not sure. Not sure. If you want to go and learn Microsoft Windows API, feel free. I mean, obviously I have, to a point, up to a point. I mean, it took me a night's sleep to work that out. Rummaging through my memory of how to do things. I mean, it's a long memory. We're talking, what, 45 years. So, yeah, I slept on that one before I put the code in. Or worked out how to put the code in, which then took, 5 minutes. Absolute crazy stuff. And I mean crazy stuff happens within this code. Is it any good? Yeah. Is it better than using a crate? Well, Bevy can't even find my graphics card. How much are people relying on crates? And that's what this brought home to me. How much do I rely in other languages on libraries supplied by other people? I've done this in C, I've done this in C++, don't worry, I've done it in all languages. It's one of the things I usually do when I'm learning a language, is the Win32 API, because it's amazingly silly. And a lot of people find it difficult. I don't find it difficult, I just find it awkward at times. But if you have a look at this, what have I actually written? Well, SDL does that. SFML does that. Those are libraries, long-standing libraries. Wouldn't it just be better to use one of those? Where other people have gone to all of this trouble. Because that's the tip of the iceberg that I've written. And the tip of the iceberg, then we have to go into converting the Windows API keyboard over to and mouse inputs and outputs over to Rust. You have to do that in C and C++ anyway. It's always the same. You end up writing quite a lot of files, shall we say. Did I bother downloading the Windows thing? No, I've only got Bevy and that ECS. Oh yeah, the ECS exploring that we did in... Ooh, we'll look at it. Remember back then, when we came to the conclusion that we'd done enough? Well, I did go back to it and I did take it one step further. Yeah, that's me for you. I'll show you what I did. So anybody who's seen the first two streams will remember back that we had a decision to make at the end, and the decision was about updating the systems, and we only came up with this. Well, I went back into this and came up with that, where I could use delta time. But how did I do that? Well, I actually had to go into the source code and alter it. And this source code is... a little problematic. Yeah, about that. It's got an error in it. According to clipping. We can actually run it. The error isn't a critical error. Luckily. But it is an error all the same. I did look at it and then realised I'd have to rewrite half of the goddamn library to do it properly. The error's there because it's an unsafe implementation, and unsafe in Rust is usually a big no-no, and I think that's saying no, you shouldn't really be doing that. I can show it to you, can't I? Control click, so it's here. It's because of that. So the code isn't wrong, it's just unsafe. But that's why I downloaded the whole thing, because I wanted to have a closer look at this. Does cause interesting ideas. So how did I get around the idea of being able to put systems in? An external implementation, I called it, where I can take in delta time like this and just call it a function. Just use a function as a system, which you couldn't do in the original thing. Well, that's not the original. That's me. I added 2 3-letter words into the code called pub. I then went through the code and got rid of a lot of the Clippy errors, about 5 of them. So I have added other stuff like hash derived default kind of thing. Why isn't this working? To get rid of some of the Clippy errors, I actually completed some of the code that should have been completed. But this is a crate that's up for grabs on Crate.io. It was the first one I came across and I just decided to use it randomly. This design choice by the original author, not having these public, made me wonder a little bit. And when I had a look at the Clippy errors, I realised why. Because it was never intended for this kind of use. But by doing that, I can now, in systems, write those 2 lines. Yeah, we can get the accessor and the manager straight from the world, rather than having to use the automated systems that have been written into the crate, which wouldn't accept delta time. It's things like that. Restricting users, or the user's ability to use your library, your crate. Which is why under the development areas I try and make things as generic as possible so they become more useful to any kind of application that I want to try out in future. Can we try that again? Thank you. Builds and runs fine. But now you can see that delta time has been included. So the original position timed is 10 and 11, and the final positions due to delta time isn't being increased. So final position timed, original position 10.16, 11.016, final position, that's the untimed, just adds 1, whereas this is adding 0.016 for 60 frames per second. So it's adding, well, 0.16, which is actually 16 milliseconds worth of velocity, rather than just adding 1. Which is important if you're trying to do animation. You want to do animation per frame, not per second or whatever. Not untimed. You want to do it timed. So there's a big difference between this and this bottom part. I just want you to do it as a proof of concept. But don't be afraid to get hold of a crate, find a problem that you can't overcome, go into the crate and see whether it is possible to change the crate to suit your application. What you can't do I'll show you what I mean, is put the crate into your dependencies here. So this is actually pathed back through to ECS Rust, which is the crate, the source code. So I'm compiling the source code and the application in the same thing. You might notice I'm in ECS Explore. Which has the ECS Dev and ECS Rust, but it's also got its own things. I'll show you how to do that. All you do is you make one of these tomls and tell it what members to have. Pretty. I don't know why we need a resolver too, but hey, that's what they told me to put, so I'll put it. I think that's the level of information that you get back out of the system when running or using Clippy. But don't quote me on that. Yeah, so I did fix that, just out of interest. It's interesting what you can do if you actually look at things. It's why I spend so much time understanding what I'm typing in, rather than just typing stuff in and saying, oh, that works. That's called programming, by the way. The typing in bit is the coding. The programming is understanding what you're typing in. I found it all interesting. Where's me readme? There it is. So that's that. I hope that's been a bonus bit of chat, because we finished under time, really. I was hoping to make it like 3 to 4 hours today, because it's Sunday. I hope that gives you a different way of looking at programming, what you can achieve in short time when you're doing things properly. But now we do have an interesting result, in that we now have development files which do things that we want them to. I don't want all of this rubbish. I wish it wouldn't do this. Open reason. I don't need all that garbage, thanks. I know what I'm doing. But thanks for the help, VS Code. Any other developments that I've been doing? Yeah, I've got this SFML stuff going on still. If you don't know what SFML is, and you want to look at it, just type in SFML, and it's the simple fast media layer, simple and fast multimedia library. It'll open you windows, it'll give you sprites, it'll give you audio, it'll even give you networking. So there's audio, types of interfacing with the C++, because the library is written in C++. There's graphics, system and window. You really... yeah, you can just chuck it all in, I suppose. Doesn't tell me how big it is. if you are going to use this, you do have to download the SFML library separately. So I do have a libraries. So in C++ we're on SFML 3.0.0. In Rust, using this crate, we're on SFML 2.5.1. We have to use this one because it doesn't link in otherwise, and we'll make a mess. So by doing that, it does mean we have to set in a couple of environment variables. So environment variables, env. Going back to the environment again, like we did with Bevy. Maybe we should put that thing in here. So environment variables, system properties, environment variables. If we have a look down here, I have SFML include, which is my library, SFML 2.5.1 include. I've put that in here. And I've also put the libraries directory in here as well under SFML lib _libs_dir. That's just so things can be found. You don't need to path it. You don't have to add it to your path. So your path stays like, you just put it into a system variable. I don't know if I need to do an environment variable. I could. Don't think I want to. So that's how I set up SFML. That came down from GitHub, just downloaded it. As long as you get 2.5.1, you're fine. Finding it is interesting. But by using that, we can actually set up stuff that works in SFML, in the SFML crate. Not sure we have to do that for SDL. The only thing is I find SDL more cumbersome. It's more involved, bigger. It's a larger library. People use it for OpenGL, but you can use SFML for OpenGL, sort of. Yes, you can. I'm not sure. I think you have to upload your own OpenGL functions. That's a different kettle of fish, isn't it? If I remember back. It's interesting stuff. So there we are. We are done, Did. I'm rather happy about that. It means that we're up for a new development. Interestingly, we could do serialization and deserialization as a separate thing. But from looking at Rust and the way it looks, yeah, you've got a crate called Serde, S-E-R-D-E, I think it is, or Serde, or Serde, which does all of that kind of thing. It seems a bit over much for what we need on currently. But it is there. What that file input output has told me is we're going to have to think very, very carefully about this is all done now. About data. And it's something that I've intrinsically understood over the years whilst programming, But this is the first time it's been highlighted by a language. And that was unexpected. It did stop me for a couple of hours thinking, what am I going to do about data? What questions should I be asking, and what answers should I be giving? Well, it's about your types of data. You should be obviously bundling them together. Now we've been talking about ECS, we've been talking about file input output. So when you're using ECS, don't use different types of data in your components. Make sure your components only have one type of data in. And there's multiple reasons for it, but we've just found one. If we want to save that data out, we're going to have to serialize it into strings, and then we can plonk it into a file. So we do need to think about the data. And that is impressive, because that's the whole point of programming. When you're programming, what is a program? It's equivalent to taking some data, passing it into a function, some people will call it an algorithm because they want to be flashy. And then you just have your result, which is a set of data. That's a program. That's every single program ever written. What you have to do is separate your data from the function and then return from the function the result. What you do with the result is up to you. You can display it on the screen in a window if you want to, but that's still the same thing. It's taking a set of data, you're putting it into a function to display it on the screen, but it doesn't return a result set of data. It may return nothing. So that's an option. So there's only really one program you can ever write. Once you realize that, programming becomes very, very simple. And it's why I split things up into different files, and usually I'll want to keep, this is why I was looking into ECS, because I wanted to keep the data separate. I wanted to have components, and that's exactly what ECS does. It's a data compression algorithm, but it keeps your data separate from your functionality, which are your systems, or it should do. If it doesn't, then you've done it wrong. So there's only one program you will ever write. There's only one program I've ever written, and that's it. That's your flowchart. That's the whole thing. Once you realise that, you can have development environments for any subject that you want. You have a main file which will call or supply a set of data for testing. Then you will do your functionality, which is what your development's all about. And the result is usually just printed out to either the console or onto a window if you want to go that far. And every game is like this as well. Every game, every application does exactly the same thing. If you can think of a way around this, good luck to you trying to program it, is one thing. But I'm going to leave it there. I think I've talked enough about the computer science of things. And I hope, some of it's been interesting. If it's helped, it's helped. If it doesn't help, it doesn't help. That's absolutely fine. Don't even worry about it. But in the meantime, I'll be back with you next week with a completely fresh idea. I think we're going to start programming now rather than just developing. I want to get away from the sandbox. Might look into that SFML thing and possibly go for something slightly different. I'm thinking of introducing myself to a different library. Goes to Amethyst RS. Oh, you would, wouldn't you? There we go. So I'm thinking of looking possibly at something called Specs, which is a parallel ECS, but it seems to have less restrictions on it. I'm not sure about the systems aspect of it. It's got the similar ideas with worlds, registering. There's no entity here. It doesn't bother with the entity much, but you can access it. I'm probably look into this a bit more. Are we going to use it? World create entity. Oh, it does have entities. Isn't that nice? This component thing can be gotten around a little bit. That's too verbose. Got a feeling I'm going to use a derive debug or derive component instead, as there is specs derive as well. Which doesn't seem to be here. Sprite. Specs sprite. Oh, it's got sprite now. Well, I'm going to be using SFML, so I won't need stuff like that. Compose spec macros. Okay. Spec time. SFML has time. We can use that. Transform. Won't need it. Builder. Blit. Blitting is just throwing things onto a screen in the simplest way possible. Static, and it's all hyphenated. Yeah, there is a specs derive. Doesn't say much about itself, does it? It's just a library. It's not a big one. So it helps us by giving us a hash derive component. So it'll do all that stuff for us. It's basically a macro to implement component. properly. Yeah, we'll probably use that because it's got a lot more stuff attached to it, including the iterators. Yeah. So that could be useful. It's one of those weird things. I'm never quite sure how libraries are going to react, but we'll see. We'll see. And we might just try out a basic game or something. See if we can get that far. I'll think about it over the week. In the meantime, thank you for popping by. It's appreciated. And I hope you're having a lovely weekend, a lovely Sunday. And yeah, go and do some programming, get a bit of practice in, because I'm now confident that I've got some of the basics worked out for Rust. I want to get past the learning stage, and I want to get into the fully fledged programming stage. So yeah, we'll see how it goes. Take care, peeps, and above all, get out there and have some fun.